All right, so question number 13 asks you to list the two unique enzymes of the glyoxylate cycle and then draw their mechanisms. And it gives you some hints on them since these mechanisms aren't actually covered in your book. All right, so the first enzyme up here at the top, this one is isocitrate lyase. The one down here, this is an enzyme called malate synthase. All right, so we're going to cover both of these. All right, isocitrate lyase. All right, what is it doing? Well, it's taking isocitrate here and it's breaking it up to form succinate and glyoxylate. All right, so I find it's really helpful in these sorts of reactions to try to find where the two different products are coming from. Well, our succinate, we have these carboxylates at either end, and a total of 4 carbons in the chain. Well, if we look at our reactant, we've got that part right here. All right, then this leaves a little 2-carbon fragment with a carboxylate on one end and an alcohol on the other. All right, so somehow we've got to split these two in half and turn this alcohol into a ketone. All right, well, how can we do that? Well, we know a lot of different ways to do these sorts of things. And one of them is, my hint says basically try doing acid-base chemistry. So, okay, what if we take a base and deprotonate the alcohol? All right, well, that leaves us some extra electrons here that can come down and form a carbonyl. All right, well, now this carbon right here has too many bonds to it. Well, we have to split these two molecules apart, so let's go ahead and cleave it right there, and why not just protonate it? Well, that's it. All right, those 3 arrows, that's the mechanism of isocitrate lyase. All right, the next enzyme is for the malate synthase. We have our glyoxylate here, and we've got acetyl-CoA. All right, and they're going to combine together to give us malate. So malate, the structure is going to be shown right here in just a second. All right, so we've got malate here as our product. Again, let's look and see where these parts are coming from. All right, well, we have this part here that just begin with that has a carboxylate on it and a ketone, and it's a 2-carbon fragment. Well, what's the closest part of the molecule to this? Well, it's this part over here where we have the carboxylate and the alcohol. All right, the other part we have we've got a 2-carbon fragment remaining, and on one end we're going to end up with a carboxylate. Well, what do we have here? Well, we have a 2-carbon fragment with a thioester on one part, so we're going to have to at some point turn that thioester likely into the carboxylic acid. All right, so how might we do this? Okay, well, this enzyme, I gave you a hint, starts off very similar to citrate, or runs very similarly to citrate synthase. Well, how does that enzyme work? Well, anytime, usually I should say, when we're working with acetyl-CoA, all right, what we are going to do is we're going to deprotonate one of these hydrogens here. All right, this creates a carbanion here that's resonance stabilized with the carbonyl. But this carbanion now can do nucleophilic attacks and attack things like carbonyls. So if we do that, what does our molecule look like in the interim? All right, well, we've got now our CoA here. All right, so that's what used to be our acetyl-CoA, and it just linked itself to this carbonyl and turned it into an alcohol. And there we go, we have a hydrogen on there. All right, so we're at this point. Now this looks really, really similar to our product. The only difference is we still have the CoA hanging out. Well, let's take a hydroxide and just hydrolyze it off. All right, so we're going to push the electrons up there like so. All right, and sorry, at this point, these can collapse back down to form the ketone or the carboxylic acid, and we can cleave off our coenzyme A and have it get protonated. Sorry, there we go. All right, so that's what the enzyme mechanism should look like here in the end. And then we have our final product, malate.